Bismillahirrahmanirrahim. My dear student, I am Dr. Muhammad Yasin. Today our lecture is about the biosynthesis and structural elucidation of ephedrine. It's my sixth lecture on the natural product. Biosynthesis and structural elucidation of ephedrine belongs to the natural product course code CAM 4119. Here is a list of key concepts that today we are going to learn. First of all, we will learn what is ephedrine. We will go towards its definition, we will see its structure. We will also discuss the biological origin of ephedrine, from which plants species ephedrine is isolated or extracted. We will have a brief discussion about the history and isolation of ephedrine. We will also discuss some of the pharmacological properties of ephedrine. Our emphasis will be on the structural elucidation of ephedrine and the biosynthesis of ephedrine. So our main topic of concerns today is that what is ephedrine, how it was isolated from the plant species. We will discuss some methods how one can isolate the ephedrine from the plant species, and we will also definitely discuss how the structure of the ephedrine was isolated, was elucidated, and what is the biosynthetic part of the ephedrine in the plant species. So these are the key concepts that today we are going to learn. Ephedrine. The most commonly known common name of the ephedrine is mohong. Mohong is a Chinese name, and the Chinese call the ephedrine as mohong. The first use of the ephedrine for the medicinal use dates back to the Chinese. It is a white crystalline alkaloid. It has a bitter taste and is soluble in water and as well as in alcohol. However, in alcohol it gets readily soluble, whereas in water it takes some time. So it is fairly, you can say that it is soluble in water and is fairly soluble in alcohol. It is mostly obtained from the ephedra. Ephedra is a group of the plant species that we are going to discuss in the latter section of this lecture. It causes constriction of the blood vessels and the widening of the bronchial passages. Since it has remarked physiological effects on the respiratory system, so it has been used in the old ages to treat the hay fever and the asthma. Today it is still used in the cough syrups, but it is placed in the government of Pakistan has placed this substance as the controlled substance. The controlled substances are those chemicals that can be used for the purpose of medication. However, the manufacturer have to keep the record of the use of that substances. So you can use this substance for cough syrup formulation, but since it is a controlled substance, so first you have to take the license from the government of the Pakistan. If we talk about the stereochemistry of ephedrine, ephedrine is found in 4 stereoisomers. The stereoisomers are those isomers that differ in the 3-dimensional arrangement of atoms in their molecules. So here I have shown you the 4 different stereoisomers of the ephedrine. If we talk about the ephedrine, the structure of the ephedrine greatly resembles with the phenylethylamine. If you compare the structure of phenylethylamine with these ephedrine, you may see that in the case of ephedrine, one hydroxyl group is present on the benzyl carbon, and on the next carbon, one methyl group is also present. The amino group, in the amino group, one hydrogen has been replaced with the methyl group. The 4 stereoisomers of the ephedrines are shown on this slide. In the first isomer on the left side on the top, you may see that the hydroxyl and methyl groups are present in R and S stereo form. The hydroxyl group is in R form, whereas the methyl group is in S form, whereas in the second, the hydroxyl group is in S form and the methyl group is on the in the R form. And in the bottom, on the left side, you may see a stereoisomer of ephedrine having 1s, 2s configuration, and it is also called as pseudoephedrine, or it is called the trioephedrine, and it is a dextrorotatory. Whereas the last one is in which the hydroxyl and the methyl groups both are in odd configuration. So its name is 1 or 2 or pseudoephedrine or negative or levorotatory trioephedrine. So these are the 4 stereoisomers of the ephedrine. However, mostly ephedrine is used for medication purposes. As I have already informed you that the ephedrine is usually found in 4 different stereoforms. So here I have listed some of the optical isomers of 1 or 2 as ephedrine, either as a free base or as acidic salts, and their physical properties are summarized on this slide. So you may see that the melting point of the free base of 1 or 2 as ephedrine is around 37 to 39 degrees centigrade, whereas the melting points of its hemihydrate form is 39 to 43 degrees centigrade. Whereas its salt with hydrochloric acid have higher melting point, and it melts at 216 to 220 degrees centigrade. Whereas its salt with hydrobromide have the melting point of 205 degrees centigrade. So here I have listed the melting points of the salts of the 1 or 2 as ephedrine with different acids. Here on this slide you may see the melting points and optical rotations of the salts of the free base and the salts of the 1 or 2 or pseudoephedrine. So on this slide you may see that the highest melting point is that of its salt with the sulfate, and its melting point is about 285 to 280 degrees centigrade, whereas the lowest melting point is for the free base of 1 or 2 or pseudoephedrine. Similarly, I have given the available data about the optical rotation of 1 or 2 or pseudoephedrine. On this slide, I have summarized the melting point and the optical rotation data of the 1 or 2 as norephedrine. So you may see that the free base have a melting point of 51 to 54 degrees centigrade, and similarly its highest melting point is observed when it forms the salt in the form of a sulfate, and in this case its melting point is 285 to 286 degrees centigrade. Similarly, its optical rotation with in ethanol, water for the free base and hydrochloride is also given, and similarly at the end of this optical rotation data you may see the optical rotation of its sulfate salt in water as well. Ephedrine. The most commonly known common name of the ephedrine is Mo Huang. Mo Huang is a Chinese name, and the Chinese call the ephedrine as Mo Huang. The first use of the ephedrine for the medicinal use dates back to the Chinese. It is a white crystalline alkaloid. It has a bitter taste and is soluble in water and as well as in alcohol. However, in alcohol it gets readily soluble, whereas in water it takes some time. So it is purely, you can say that it is soluble. As I have told you that the ephedrine is a controlled substance and can be used for medical purposes. Most of the L-ephedrine produced today for official medical use is made synthetically, so it is prepared in the laboratory. The extraction and isolation process from Ephedra sinica is tedious and no longer cost effective. The pictures of the Ephedra sinica plants are shown on this slide, so one can readily recognize the Ephedra sinica and can also isolate or extract the ephedrine, L-ephedrine or the other isomers of the ephedrine from this plant species. History of ephedrine dates back to the Chinese. In the China, the ephedra is known as Mo Huang. The literal meaning of the Mo Huang is hemp yellow. It is a Chinese shrub known for at least 5,000 years ago. A Chinese emperor Shen Nong in 2700 before the birth of Christ cataloged the 365 medicinal herbs in the terms of their bitterness. Shen Nuang classified the herbs into three main groups, namely the strong, medium and mild. Shen Nuang placed the Ephedra in the medium group. In the 16th century, another Chinese, Li Shi Shen, produced a dispensatory, namely the Pansao Pang Mo, in which he clearly described the Ephedra shrub. In the China, the Ephedra herb was said to be useful as circulatory stimulant and as diaphoretic and antipyretic drug. Diaphoretics are those drugs that cause heavy perspiration, whereas the antipyretic are those drugs that are used to relieve the fever. So in the China, it was also believed to be useful in the treatment of fever and cough. So the first historical use of the ephedrine that have been discovered dates back to the China in 2700 years before the birth of the Christ. At the end of the 16th century, dried stems were exported to Japan, a trade which was to play an important part in stimulating the trust of Japanese physicians and chemists in the Ephedra plant some 300 years later. Other species of Ephedra, which were literally recognized as Ephedra petriculata and Ephedra intermedia, were thought to have medicinal value, were found in Greece, Russia, India and in America. Various religious groups, including Hindus and Parsis, use these species in their religious ceremonies to produce the feelings of exhilaration. So we have some evidences that the Hindus and the Parsis have been using the Ephedra plant species in the subcontinent for the religious purposes to produce the feelings of exhilaration. However, there are solid evidences that the Chinese were the first nation who were aware of the medicinal importance of Ephedra. Here is a list of key concepts that today we are going to learn. First of all, we will learn what is ephedrine. We will go towards its definition, we will see its structure. We will also discuss the biological origin of ephedrine, from which plants species ephedrine is isolated or extracted. We will have a brief discussion about the history and isolation of ephedrine. We will also discuss some of the pharmacological properties of ephedrine. Our emphasis will be on the structural elucidation of ephedrine and the biosynthesis of ephedrine. So our main topic of concerns today is that what is ephedrine, how it was isolated from the plant species. We will discuss some methods how one can isolate the ephedrine from the plant species, and we will also definitely discuss how the structure of the ephedrine was isolated, was elucidated, and what is the biosynthesis. In 1997, Federal Drug Authority proposed a regulation on ephedrine, which limited an ephedra dose to 8 mg with no more than 25 mg per day. This proposed rule was withdrawn in part in 2000 because of concerns regarding the agency's basis for proposing a certain dietary ingredient level and a duration of use limit for these products. In 2004, the FDA created a ban on ephedrine alkaloids marketed for reasons other than asthma, cold, allergies, other diseases, and traditional Asian use. On April 14, 2005, the U.S. District Court for the District of Ottawa ruled the FDA did not have proper evidence that low dosages of ephedrine alkaloids are actually unsafe. But on August 17, 2006, the U.S. Court of Appeals for the 10th Circuit in Denver upheld the FDA's final rule declaring all dietary supplements containing ephedrine alkaloids adulterated and therefore illegal for marketing in the United States. Furthermore, ephedrine is banned by NCAA, MLB, NFL, and PGA. Ephedrine is, however, still legal in many applications outside of dietary supplements. Purchasing is currently limited and monitored with specifics varying from state to state. To summarize, the folk medicine claims up to the 1880s, it would seem that ephedra did have some therapeutic actions, perhaps in prevention and treatment of venereal diseases and possibly in treatment of cough and respiratory complaints. If we talk about the legal boundaries of the use of the ephedrine in Pakistan, ephedrine is placed as the controlled substances. So the ephedrine is a controlled substance. The controlled substance means that one can use the ephedrine for medical purposes. However, the manufacturer have to maintain the full record of its use. If we talk about the stereochemistry of ephedrine, ephedrine is found in 4 stereoisomers. The stereoisomers are those isomers that differ in the 3-dimensional arrangement of atoms in their molecules. So here I have shown you the 4 different stereoisomers of the ephedrine. If we talk about the ephedrine, the structure of the ephedrine greatly resembles with the phenylethylamine. If you compare the structure of phenylethylamine with these ephedrine, you may see that in the case of ephedrine, one hydroxyl group is present on the benzyl carbon, and on the next carbon, one methyl group is also present. In the amino group, one hydrogen has been replaced with the methyl group. The 4 stereoisomers are. If we talk about the physical appearance of ephedra, ephedra are usually small shrubs with slender, angular, and striated branches whose leaves are reduced to membranous scales, presumably to reduce the transpiration in the arid, windy areas where they survive. So here on this slide, you may see the picture of the ephedra plant. If we compare the distribution of ephedrine among the different ephedra species, the Chinese and the subcontinent species of ephedra make significant amounts of active compounds. These species include Ephedra seneca and Ephedra equisetina in China, and Ephedra intermedia and Ephedra gerardiana in subcontinent. These 4 species of ephedra contain significant amounts of ephedrine if we compare them with the rest of the ephedra species. Ephedra seneca, Ephedra equisetina, Ephedra intermedia, and Ephedra gerardiana, by owing to the high concentrations of the ephedrine, these species are the major commercial source of ephedrine alkaloids and would in time be shipped all over the world, in particular to the Americas and Europe. However, nowadays, new cheap alternative synthetic methods for the synthesis of ephedrine are available, and the majority of the ephedrine is now prepared synthetically rather than the extraction from these species. If we talk about the discovery and the isolation of ephedrine, the name of a Japanese professor Nagoshi Nagai comes first. He is the central figure in the first era of scientific work on ephedrine. He studied medicine at the Dutch Academy in Nagasaki and completed his studies in Tokyo. He was the first doctor of pharmacy in Japan. In 1869, the Japanese government lifted the ban on their graduates gaining further training outside the country, while at the same time allowing the foreigners to come in for trade and other purposes. Nagai was sent under government scholarship to Germany in 1871 to study at the University of Berlin. He was the only civilian in a group of military students sent to study in Great Britain and France, and he traveled by way of the United States and Great Britain. While in Berlin, he resided at the home of a Japanese diplomat. He was influenced by the lectures of von Hofmann and received a doctorate with a study on eugenol. While working as an assistant at von Hoff's laboratory, he decided to take up organic chemistry in 1873. Nagai returned to Japan in 1883 to take up position at the Tokyo Imperial University and became professor of chemistry and pharmacy there in 1893. His research centered on the chemical analysis of various Japanese and Chinese traditional herbal medicine. While in Germany, Nagai married Therese Schumacher, the daughter of a wealthy lumber and mining magnate. On their return to Japan, she became a professor of German language at Japan's Women's University and was active in introducing the German foods and culture to Japan. In 1923, Nagai and his wife hosted Albert Einstein and his wife during their visit to Japan. As first president of Pharmaceutical Society of Japan, founded in 1818, Nagai had an important impact on the propagation of chemistry and pharmaceutical sciences in an industrializing Japan. It's my sixth lecture on the natural product, biosynthesis and structural elucidation of ephedrine belongs to the natural product course code CAM 4119. If we talk about the physical appearance of ephedra, ephedra are usually small shrubs with slender, angular and striated branches whose leaves are reduced to membranous scales, presumably to reduce the transpiration in the arid, windy areas where they survive. The ability of an ephedrine to dilate the pupil was readily reversible with time, in contrast to the prolonged and possibly dangerous action of the tropine alkaloids such as atropine and homatropine. This use of ephedrine as mebariatric drug did not gain general acceptance. After the studies of Kimura on L-ephedrine, there was then a gap of 30 years in which ephedrine remained in limbo until in 1913 when Amatsu and Kubota from Japan reinvestigated the action of the ephedrine. To their surprise, they found that L-ephedrine was symptomatic agent in that it could raise the blood pressure and accelerate the heartbeat. The Japanese scientists Amatsu and Kubota also noticed that ephedrine, like adrenaline, was capable of relaxing bronchial smooth muscles. Therefore, they suggested that it could have therapeutic potential in the treatment of bronchial asthma. Following this work, an ephedrine-containing medicine was marketed in Japan for asthma. It was named as asthmatol, but having little or no success, it fell into disuse. Here on this slide you may see the melting points and optical rotations of the salts of the free base and the salts of the 1 or 2 or pseudoephedrine. So on this slide you may see that the highest melting point is that of its salt with the sulfate, and its melting point is about 285 to 280 degrees centigrade, whereas the lowest melting point is for the free base of 1 or 2 or pseudoephedrine. Similarly, I have given the available data about the optical rotation of 1 or 2 or pseudoephedrine. As I have already informed you that the ephedrine is usually found in 4 different stereoforms. So here I have listed some of the optical isomers of 1 or 2 as ephedrine, either as a free base or as acidic source, and their physical properties are summarized on this slide. So you may see that the melting point of the free base of 1 or 2 as ephedrine is around 37 to 39 degrees centigrade, whereas the melting points of its hemihydrate form is 39 to 43 degrees centigrade. If you want isolate or extract the ephedrine from a biological source, the first thing you need is the dried young stems of Ephedra sinica or Ephedra equisetina or Ephedra intermedia or Ephedra gravidiana. I recommend these species, plant species, because these plant species contain maximum amount of ephedrine. However, one may use any of the plant species of genus Ephedra. In these plant species, ephedrine is stored either in the form of ephedrine or N-methylephedrine or norephedrine or pseudoephedrine. Here is a list of key concepts that today we are going to learn. First of all, we will learn what is ephedrine. We will go towards its definition, we will see its structure. We will also discuss the biological origin of ephedrine, from which plants species ephedrine is isolated or extracted. We will have a brief discussion about the history and isolation of ephedrine. We will also discuss some of the pharmacological properties of ephedrine. Our emphasis will be on the structural elucidation of ephedrine and the biosynthesis of ephedrine. The acidic solution is made alkaline with solid potassium carbonate, and the liberated base is then extracted with chloroform. The chloroform solution, when dried over anhydrous sodium sulfate and distilled, give 2.6 grams of crude ephedrine. This crude ephedrine is then recrystallized out from a proper solvent to give the pure crystals of ephedrine hydrochloride. The purification of the obtained crude ephedrine is performed by dissolving the crude ephedrine in alcohol, followed by its neutralization with concentrated hydrochloric acid, and then again dilute it with alcohol. Nearly pure ephedrine hydrochloride salt is crystallized out on staining. Wash these crystals with a mixture of alcohol and ether and then dry it. This will give you the pure crystals of ephedrine hydrochloride. Here is the second method for the extraction and isolation of ephedrine. First of all, take great quantity of the dried young stems of ephedra and powder them to obtain the pore-sized particle. Extract the ephedra powder with petroleum ether. Petroleum ether will separate the oils and other species material. Filter the petroleum ether and discard the ether extract containing the oils and fats. Dry the ether extract residue and moisten it with dilute ammonia. Now filter and evaporate the filtrate to obtain dry residue of ephedrine. TLC or the thin layer chromatography method is a simple method that can be rapidly used for the estimation of ephedrine in the test solution. First of all, you have to prepare the test solution. For the preparation of the test solution, extract about 5 grams of freshly powdered drug with 50 ml of methanol by shaking for 30 minutes in a conical flask. Filter and concentrate the filtrate under vacuum to about 5 ml. Secondly, you have to prepare the standard solution of ephedrine. For this purpose, you should have pure sample of ephedrine. Dissolve 5 mg of pure sample of ephedrine in 10 ml of methanol will give you the standard solution of ephedrine. This standard solution of ephedrine will be used as a reference material on the thin layer chromatography plate. Third thing that you need for the estimation of ephedrine in the food or in the drug sample is the solvent system. The solvent system comprises of chloroform, toluene and ethanol. Add 3 parts of chloroform into 6 parts of toluene and followed by the addition of 2 parts of ethanol will give you a solvent system that can be used for the development of chromatogram. Now apply separately 10 microliter each of the test and the reference solution on a pre-coated silica gel 60 TLC plate. Develop the TLC plate in a solvent system that I have mentioned, comprises of 3 parts of chloroform, 6 parts of toluene and 2 parts of ethanol. Develop the TLC plate until that the distance of the solvent front reaches to 8 cm minimum. Now dry the TLC plate in a front of half A. After this, you have to develop the TLC spots. For the visualization, now you have to spray the air-dried TLC plate within hydrogen region and heat the TLC plate at 110 degrees centigrade for 5 minutes. Note the RF value and compare the RF value of the ephedrine if found in the drop sample with the standard RF value of the ephedrine. Usually, if the ephedrine is present in your drop sample, a reddish-purple band will appear in front of the reddish-purple band of the standard solution. If we compare the distribution of ephedrine among the different Ephedra species, the Chinese and the subcontinent species of Ephedra make significant amounts of active compounds. These species include Ephedra seneca and Ephedra equisetatina in China and Ephedra intermedia and Ephedra gerardiana in subcontinent. These 4 species of Ephedra contain significant amounts of ephedrine if we compare them with the rest of the Ephedra species. For the preparation of the standard solution or for the reference solution, prepare 1 mg per ml of the stock solution of ephedrine in methanol, pipette out allocates of 0.5 to 3 ml in increments of 5 ml into 10 ml volumetric flask and make up the volume of each flask with methanol. This will give you the standard solution. Most of the HPLC are coupled with UV visible spectrophotometer. So first, when you run the reference solution through the HPLC will pass the ephedrine into the UV visible spectrophotometer. The spectrophotometer will give the intensity of the absorption as the concentration of the ephedrine in your reference sample. Similarly, now run your drug sample on the HPLC. HPLC will separate out the ephedrine at the same retention time as for the reference solution and then pass it to the UV visible spectrophotometer. The UV visible spectrophotometer will give the absorption of the ephedrine at a particular wavelength. The absorption intensity will correspond to the concentration of ephedrine in your drug sample. So upon comparing the reference solution and the test solution, you will have a retention time. The retention time for the ephedrine is estimated from the reference solution, and the concentration of the ephedrine in your drug sample is estimated on the basis of the intensity of the absorption. Biosynthesis of ephedrine and pseudoephedrine of ephedra begins with L-phenylalanine that I have denoted with PHE. L-phenylalanine is the initial precursor of ephedrine and pseudoephedrine and catalyzed by phenylalanine ammonium lyase that I have denoted or represented with PAL, that is additionally highlighted in green color. Recent studies suggest that there are at least two possible pathways of L-phenylalanine side chain shortening in ephedra. These two pathways are denoted with or represented with pink color and the blue color on this slide. The first one on the right side of this slide is non-beta oxidative coenzyme A independent pathway, and the other is beta oxidative coenzyme A dependent pathway. In the beta oxidative coenzyme A dependent pathway, the first step is the formation of cinnamyl coenzyme A, which is catalyzed by cinnamate coenzyme A ligase. Subsequently, a hydratase converts the cinnamyl coenzyme A to 3-hydroxy-3-phenylpropanoyl coenzyme A, and a dehydrogenase catalyzes the 3-hydroxy-3-phenylpropanoyl coenzyme A into 3-oxo-3-phenylpropanoyl coenzyme A. In the end, 3-ketoacyl coenzyme A thiolase catalyzes the formation of benzoyl coenzyme A. In the non-beta oxidative coenzyme A independent route, cinnamic acid is converted to 3-hydroxy-3-phenylpropanoic acid under the catalysis of hydratase. After retroaldo cleavage, 3-hydroxy-3-phenylpropanoic acid is converted to benzaldehyde. Subsequently, two different dehydrogenases, that is benzaldehyde dehydrogenase and aldehyde oxidases, catalyze the formation of benzoic acid from benzaldehyde. After undergoing condensation with pyruvate, benzaldehyde, benzoyl coenzyme A and or benzoic acid is catalyzed by THDP dependent carboligase to form the 1-phenylpropane 1,2-diene. So in this slide you may see the conversion of L-phenylalanine up to the conversion of 1-phenylpropane 1,2-diene by two pathways. The two different pathways are represented with two different colors. The next slide will start from the conversion of 1-phenyl 1,2-diene and so on. For the visualization, now you have to separate the air-dried TLC plate within hydrogen region and heat the TLC plate at 110 degrees centigrade for 5 minutes. Note the RF value and compare the RF value of the ephedrine if found in the drop sample with the standard RF value of the ephedrine. Usually, if the ephedrine is present in your drop sample, a reddish purple band will appear in front of the reddish purple band of the standard solution. Chemical structural formula of ephedrine and pseudoephedrine were first studied by Ladenburg and Elucidation. They suggested a chemical structural formula for the ephedrine and pseudoephedrine, which is shown in red color on this slide. Schmidt and Booming confirmed their finding, and hence their structural formula were accepted worldwide. Another remarkable property of the ephedrine and pseudoephedrine is that these are the stereoisomers of each other. For example, ephedrine isomerized to pseudoephedrine by acylation or by boiling with 25% hydrochloric acid. Another thing that is remarkable about the ephedrine and pseudoephedrine that they are interconvertible to each other, as well as these changes are reversible. Freudenberg and Lethe investigated the C1 and C2 configuration of ephedrine and pseudoephedrine. They suggested the following chemical formula for the ephedrine and pseudoephedrine. If we talk about the stereochemistry of ephedrine, ephedrine is found in 4 stereoisomers. The stereoisomers are those isomers that differ in the 3-dimensional arrangement of atoms in their molecules. So here I have shown you the 4 different stereoisomers of the ephedrine. If we talk about the ephedrine, the structure of the ephedrine greatly resembles with the phenylethylamine. If we compare these, at the end of this lecture, here is a list of recommended books. You may consult any one of these books. Thank you very much.